Alright, hi everyone, so welcome to my YouTube channel, City of Elections. So this is the second video of this series, Arduino project handbook. So in this video we're talking about this guy. This is the second project, light dimmer. So in this project you create a dimmer switch by adding a potentiometer to control the brightness of an LED. So this is what we have here. So this is the potentiometer. Once you turn this left or right, you affect how bright this LED is. Alright, so let's go into making the video. So of course, input output, input process output. So what will serve as our input to give us input signal is this guy. Okay, this is the potentiometer, right? Potentiometer. So it's a resistor, but variable resistor. Think of it like your usual normal resistor, the ones we are used to. These guys, think of it as these guys, but for these the values are fixed. If it's 220 ohms, that's it. If it's 1 kilo ohms, that's it. But for this guy, the resistor value can be changed. While as you adjust this knob here, as you adjust this, the value of the resistor, its value changes. And you know, for the relationship, there's a relationship, there's a relationship between voltage, current, and what? Resistance. So based on Ohm's law, voltage equals IR, which is current multiplied by resistance. So meaning if you adjust the resistance, you are actually affecting the amount of voltage. So this is we serve as our input to what? The microcontroller, which we serve as our processor, okay, to process the whole thing. So when this guy gives inputs to this to the microcontroller, what the microcontroller receives from this is actually voltage. Voltage is read from this, and you know this thing is what is continuous in time. This keeps giving values continuously. So that's analog, since the reading is continuous. So analog, that means we have to connect this one to where? The analog pin of the Arduino. Look at it, these pins, we'll connect it to any of this one. We can start from 0, okay, A0. So we'll connect this guy there. So these are the guys we need. And then for the one that will serve as our output, of course we use light emitting diode output, our LED, and one resistor. I think I will use 220 kilo ohm, 220 ohms resistor. This is not all right. Okay, so for the 220 we know we should see red, but we are now red. Yeah, that's it, 220. So good. Then of course jumper wires. All right, so I think we're done. What else? That's it. Then of course breadboard. How can I forget this? Breadboard. And if you watch our previous videos, you know why we need breadboard, just to hold the components together. So let's make our connections. So first things first, let's put our input in place. So just pick any point. We'll just pick any point. Now, if you look at this, you will see something. There are 3 pins, right? Now, the center pin is what gives out reading. Okay, the center pin is what gives out reading. So let me connect it like this. So just look at it carefully where it's going to. All right, we have that guy in place now. So the center pin is going to Arduino the analog inputs. Then the left and the right, one will go to ground, one will go to one will go to negative, which is ground, the other will go to positive, which is live. That's the 5 volts of the Arduino. Note, whichever side, left or right, whichever one goes to ground or live, it doesn't really mean, but just that if you switch the side, and where it affects is this thing, okay? This will mean to reduce the value. This, let me take it closer. This will mean, this will mean to increase value, this will mean to reduce value. But if you switch it, positive and negative, if you switch the side, this side will now mean the opposite. They will just change sides. We'll do that so you see when it's all connected. So, okay, so let me connect this guy now. So all I have done is just connect ground. Come on, contrast, bro. I mean, focus. Yeah, connected ground. Okay, to that. Then, so at this point, we can do this. Connect positive and negative. So this guy is the positive. Like I said, any side can go for positive, okay? Just like if you switch the side to affect what left and right means. Good. So let me send this one to positive for now. This one here. Good. Meaning our program I'm going to use A0 for it. All right, so we have our input well connected. So now for the output, which is the LED, I believe we already know how to connect that already. Longer leg or something. Longer leg. So let me put that here. Put that here. And of course, we connect a resistor between the longer leg. Now, this guy is not directly controlling the LED. Please bear that in mind. This guy, the voltage reading gotten from the potentiometer, this is a potentiometer of course, is not directly controlling the LED, the brightness of LED. It is only giving us values. It is only giving us different values, different voltage reading. That voltage reading we receive to control the brightness of the LED. Now, if you look at these pins, you will see. If you look at these pins, I think I should unplug this thing now, so you can see it. Hope you can see this. If you look at these pins, you will see this some little dash, small dash, small dash, small dash. Now, what those dash mean is that this pin can be used for pulse width modulation. Okay, so this is what I want to show you. Now, the pulse width modulation, this is a pulse, okay, but this pulse lasts for some period of time. You see this distance from here. Actually, I can write on this edge browser. Okay, so you see that the pulse lasts from here to from this part. Okay, you see the distance from here, from this part to this part. You see the size of it. Now this size is the same all through. Okay, so for one circle, for one or let me say clock pulse, or let me say one period, of course the microcontroller has internal timer. So for one, let me just say one circle, okay, or for one, let me say one circle. So for one circle, the LED stays on for what? If we have a let me take this thing guys out. So if we say we have let's say like 1 volt coming in, 1 volt coming in from our potentiometer, what does that mean? It means that the LED is what? Is on for 20% of the time. Okay, so 20% of the time, and then it's off for 80% of the time. So now 1 volt means that it will go on and off, on and off, on and off. That's the pulse width modulation. On, off, on, off, on, off. But this on, off, look at it. This on and off, it is only on for 20% of the time. 80% of the time, it is not on. Okay? So this on for only 20%, off for 20%, off for 20%. What am I saying? This on for 20%, off for 80%, on and off, switching between on and off. This is pulse, this is the width, and this switching on and off, on and off. It like we are modulating between, let me say we are modulating between on and off. Okay, so this is the pulse width modulation idea. And because it's on for 20% of the time, that means 20%, that's 0.2 multiplied by the full voltage. If it's on completely, that is 5 volt. So 20% of 5 volt, that means it's 1 volt. So we are going to perceive, our human eyes will perceive the light as if we are getting 1 volt. Look at this thing called persistent vision. Persistent vision here, I think somewhere here. Yeah, look at it. So the LED is actually being switched on and off, but it happens so quickly that our eyes compensate and we see a continuous lit LED at varying light levels. This is known as persistence of vision. So but what if the voltage we get in, we send in from the potentiometer, if we are using that voltage from the potentiometer, and it happens that the voltage, maybe when we adjust it at the potentiometer, we are getting 2.5 volts. It means that the LED will be what? On for 50% of the time. Look at it. High signal for 50% and low for 50%. So the output will be what? 0.5 times 5 volts, which is the maximum volt, we give you 2.5. Meaning on for half of the time, off for half of the time. This switching will now make us perceive it as if it's half voltage. So this is not just this 1 volt and 5 volts. You can have 1.5, 1.1, depend on how you vary the potentiometer or the variable resistor. So also for this guy, okay, so it's just on for 80% of the time. So this one will look brighter. And if it's you are giving incomplete 5 volts, it will be on for all through, and you perceive it like it's fully on. Okay, so with that being explained in the book, now we understand why I'm going to use another pin. I think pin coming from top, pin 12 doesn't, pin 13 doesn't have that, pin 12 doesn't have that, pin 11 has that. So wait guys, I forgot to add something. Can you imagine? I forgot to add as a connect negative LED. So ground. Okay, so now this is complete. Thank you. So of course, I think we should be used to this by now. Variables. So that means what we are going to make use of in the program, instead of saying the pins, we'll use something we can relate with. So LED. Now any pin you see this sign, any pin you see that sign, you know that you can do pulse width modulation with it. So we connect. That's why I connected it to what? To pin 11. Okay. Oh, I forgot the int. All right. Then for the potentiometer. Do I need to write everything? Just port to be okay. Potentiometer. That one is what? A0, analog 0. You have to put the A in this case. Then for our setup, pin mode for LED is what? It's the output. If you follow this series, I think I should not hit over this too much, but then that's for the LED. So since the LED is giving us output, so the pin mode will be what? Output. Okay, that's a mode of the pin. This pin mode is a keyword. Then how about setting the pin mode for potentiometer? No need, because if you look at the Arduino, the board, the potentiometer. Why am I opening this? You look at the potentiometer. The Arduino, you will see that this pin A0 is already analog pin. We don't need to. Sorry, it's already analog in. It's already an input pin. We don't need to declare or state that is an input. Okay. So that one is stated on its own, so you can leave that. You don't need to add that in terms of pin mode. Then I like to put this close set up so that I know where this curly brace. I know what this curly brace covers. So then for our loop, we'll do what? We read. Let me just put this. Read the value from the potentiometer. Okay, so how do you do that? Since that pin is what? Analog pin, and you want to read the value, you want to take the value, you say what? Analog, then what? Read. What are we reading? The potentiometer. Okay, now that value we get from the potentiometer, we have to save it inside somewhere. So let's call it, let's save it inside value. Let me just call it value. Okay. But of course, that value is coming in. It's an integer, so let me just declare it here. Int value. Okay, declared. So it is this value we are going to make use of in doing what? This is the value we are going to make use of in doing what? Control the brightness of the LED. So this value we receive. So this value we receive from the potentiometer is what we are going to use to control the LED. Now note that since the LED is in a pulse width modulation pin, it's going to behave as if it's analog. Because if we use digital write, if we use this, digital write will only give us what? On and off, high or low, 0 volts or 5 volts. But we want to have the option of having voltage in between 0 and 5. 0, 1, 1.5, 2, like that to 5. So it's not digital like per se. Okay, so we are going to say what? Analog write. Okay, so the analog write, the value we are going to write into this particular one, that value will be what? The value we get from the potentiometer. However, based on how the Arduino is built, based on how this our microcontroller is built, the input pin is what? This one I think I need to write it somewhere off first. Let me just see if I can just use somewhere to write this roughly. So let me just use here. So the input is what? It's 10 bits. Okay, 10 bits. 10 bits meaning 2 raised to power what? 2 raised to power 10. Okay, and 2 raised to power 10 is what? 1204. Okay, so this is not from us. This is from the hardware design of the microcontroller. It is the input pin. That analog input pin is a 10-bit pin. Okay, or it works with, let me say it works with 10 bits. So we are getting values from 0 to what? 1004. 1023. This is 1004 now. 0, 1, 2, 3, 2. This one is 1024. Okay. However, for the output pin is what? It works based on 8 bits, and 8 bits is 2 raised power 8. That is what? That's what? 256. Okay, and of course that means the range goes from 0 to what? 255. Okay, so with this, that means our input is coming as this, but our output is going as this. That means we have to match these values to these values. So the highest for the input is this, the highest for the output is this. Okay, the lowest, of course, they are the same. So what we have to do in order to match them, so divide this and this. Let me just write here. We'll forget the range for now. Okay, and this one is 256. Now divide this number by 256. You will get what? 4. Okay, meaning changing this input, which is this value, so that it will match our output, is to divide this input by what? 4. So in this case, it will correspond correctly. That means if we are receiving the full input voltage from this input, which is 1203, okay, we are going to get the full output, which is what? 255. Note, I'm saying 255 because the number of possibilities is 256 if you start counting from 0. For this one, I'm saying 1023, but it's actually 1024, because if you start counting from 0, you will land at 1023. You can drop comment in the comments section to maybe get clarity, or ask in case that thing is not clear. So here I just say close loop, and that's it. So now we can run this program successfully. Okay, connect this guy. Okay, connected, and then I'll load in the program. Okay, I don't have to switch. Let it just load. Yeah, it's on, but I think when I was rearranging, I switched this thing. This is 11, correct? Good. Can we see that? So you see that it's, I think, let me look at the camera to be sure you guys can see this. So when you turn this way, you see it brights up gently. Okay. Yeah. No kidding. Brightness. So let me switch it and let's see what's going to happen. When you take the positive and switch with the negative, switch to the negative, but enter. Switch to the negative. Good. So now the positive is at this side now. So this side now, this way now means bright. This way now we mean, sorry, what's happening? Oh, good. Now so you observe now this side means what? Bright. This side now means what? Get dim. So dimmer. So you see, it's just the opposite. So whichever way you connect it, it will work. Just that if you put the positive here it becomes bright. Put the negative here it becomes, that's just it. Okay, so I think I should turn off the light and see how it looks. Alright, so thanks a lot for watching. Like, share, subscribe, and I'll see you in the next video. Thank you for this battery.